Not yet. I think it's coming. Yes, now we can see your screen.
Okay, thank you. I'm gonna start my presentation. Good afternoon, ladies, gentlemen, judges, and professors. First of all, we would like to thank you to the IEOM Society for the opportunity to present one of our research with the title is Spring Bed Production Floor Relayout using SLP, Core Lab, Craft, and Block Plan method with Pro Model and Flexim simulation. Our group consists of 3 members, including me, Geraldo Rafael, with my friend Christie and Natasia, and our supervisor, Dr. Lamto, Dr. Adianto, and Dr. Lina.
The outline of the presentation that will be discussed is starting from introduction, literature review, method, result, and discussion, and last for conclusion. Next. Start from introduction. PT Alpha Jaya Manunggal Mandiri is manufacturing company engaged in the furniture sector to produce couch, bed frame, spring bed, pillow, and each other. The distance between workstation is far from each other and has an alternating process flow, make it less efficient.
This is the identifications of problem of this research. And this is the research purposes of this research. So this is the scope of this research.
For the literature review, there are 6 literature used to the research. The research include systematic layout planning, software pro model, doctrine, Core Lab, Craft, and Flexi. Next. And this is the method of the research, which can be seen in the screen. Next. And this is the production flow for the research. Next.
And next, this is the initial layout of PT Alpha Jaya Manunggal Mandiri. As you can see, the layout. Next. And next, we move to the work element. Here, we collect 30 times for the data of the work element, and we conduct the normality test, sufficiency test, and also uniformity test. Next. This is the result of the normality test, which we use the Anderson-Darling method, and the p-value of our work element is greater than 0.005, so the data is called normal. Also, for the uniformity test here, you can see there is 3 sigma we use, which the scatter doesn't pass through the UCL and LCL, so the data is uniform.
Wait for a moment. Can you just wait for a moment? I would like to audience everyone, please mute yourself. Please mute yourself. Everyone, audience, everyone, please mute yourself. Go ahead.
Okay, next, this is the uniformity test, which the scatter data doesn't pass through. And now this is the next, this is the sufficiency test, which we use the confidence level of 94% and significance level of 5%. And as we can see here, on the work element, the number of observation data is greater than number of theoretical data. So the data we call sufficient. Next.
And this is the time study of the spring bed production, which consists the cycle time, rating factor, normal time, allowance, and standard time. And the way to get the normal time and standard time can be seen on the screen.
And this is the operation process chart for spring bed production at PT Alpha Jaya Manunggal Mandiri. Next. And this is the flow process chart for the spring bed production, which can be seen in the screen. Next. And for the floor area with a 20% allowance, the total area range of 2,190 square meters. Next. And this is the spring bed production material block flow diagram, which can be seen in the screen. Next.
Next, this is the bill of material on spring bed production line. As we can see here, there is the level on producing the spring bed. Next. Next, this is the spring bed sales data from 2012 until 2021, which gonna be used for the forecasting next 10 years. Next. And next, with using the help of software QM for Windows, we do some forecasting with several methods, which the lowest error gonna be used as the forecasting method, which this time is the linear regression method have the lowest error. Next. And next, this is the result of the forecasting using the linear regression method, which for the year 2023 until 2032, that gonna be used for the routing sheet data. Next.
In creating the routing sheet, production data is used based on forecasting the number of spring bed demand in 2022, which we can see in the slide. And this is the routing sheet for the spring bed production line based on the routing sheet data. As we can see here, this is the component for the spring bed production, which as we can see, the production efficiency have least step and total step are 39, and the efficiency is 100%.
And this is the number machine needed. Next. And this is the activator relationship chart for spring bed production line. Next. And this is the activator template block diagram for spring bed production line. Next. And this is the activator relations diagram of spring bed production line made into alternative, which can be seen in the alternative 1 and alternative 2. Next.
Okay, next we continue the step for the SLP method by creating area allocation diagram, which is this is the SLP method for the alternative 1. Next. And this is the material flow alternative layout 1 for the SLP method. Next. Next, this is the area allocation diagram we create for the alternative 2 using the SLP method. Next. And this is the material flow for the alternative layout 2 using the SLP method.
For alternative layout processing using Blockpen software, there's 20 alternative layouts were created using Blockpen by considering the level of proximity of each workstation based on the activity relationship chart. The proposed layout that was chosen was alternative layout number 1 because it has the highest adherence score and minimum real distance score, which was then designed using Blockpen software, which we can see in the slide. And this is the area allocation diagram based on the Blockpen method.
Next.
This is the material flow alternative layout based on the Blockpen method.
Next, we're gonna move to the correlate method here. For the correlate method, first we're gonna calculate the total closeness rating based on the relationship from the activity relationship chart on the slide before. The total closeness rating gonna be used for the determine the ranking of workstation. Next. This is the ranking for the based on the total closeness rating that gonna be used for the iteration of every workstation. Next. In core lab, we're gonna use some iteration until the workstation can be placed for the area allocation diagram, which there is 14 iteration, and this is the final iteration. Next. This is the area allocation diagram for the core lab method based on the iteration. Next. And this is the material block flow alternative layout for core lab method. Next.
This is the result of the layout designing using software for the craft method. The craft method is used to find the minimum result of the iteration of 5 to 10 times. Next. This is the area allocation diagram craft method. Next. And this is the material flow alternative layout craft method.
And this is the material handling cost for the old layout. This is the material handling cost based on the SLP method for alternative 1. And this is the material handling cost based on the SLP method for alternative 2. And this is the material handling cost based on the Blockpen method.
This is the handling cost correlate method. Next. And this is the material handling cost craft method. Next. The comparison of material handling cost result of the 6 alternative with the conclusion the lowest material handling cost per week is a layout of SLP method alternative 2. Next. And
Next
this is the new layout spring bed production line.
Next, we're gonna move to the Pro model simulation here. As we can see for the Pro model simulation, this is for the all layout, which the result of the Pro model simulation for all layout can produce for 1 year is 9,816 units, which can be concluded cannot fulfill the product demand because the product needed to be produced is 10,244 units. So it's necessary to create and implement a new layout design. Next. And for the proposed new layout, as we can see here, there is some increase on the production for 1 year is to become 11,317 units, which can be concluded that can fulfill the product demand for 1 year, and also decrease the average time in operation and average time in system. Next.
As we can see here, the purpose layout decreased the material handling cost, which decreased by 50.12%, with movement decreased by 17.86%, and decreased the distance for spring bed production process, which decreased by 53.42%, also increasing the total production per year by 15.29%.
Next, I'm gonna start the FlexSim simulation here. I'm gonna share my screen first. As we can see here, for the FlexSim simulation, there is some block here. So one block is count as 1 meter. And also, when I'm gonna start, this is the simulation. When I'm gonna start it for 8 hour, which is the shift work 1 day for the layout, there is gonna be a data on the dashboard, which is output per hour and stay time. This is the processing process, which we gonna input some time, such as processing time and also the setup time. And for 8 hours, when I'm fast forward it, there is some result which can be seen here. This is the output per hour for every workstation, which is the workstation here. Tap etch and packing process in the final workstation can produce 3.75 unit of spring bed per hour, which can be summary in 29 unit for 1 day. And also this is the stay time. And when I'm gonna simulate the new layout here, I'm gonna open the file. This is the simulation for the new layout. As we can see, when we create the new layout, there is some decrease on the distance between every workstation, like the research state, and also when there is some decrease on processing time and setup time. So when we implement the new layout here, when we finish, there is some increase, which can we see here on the screen. There 5.75 unit, which increased to unit per hour, and also there is some decrease on the state time. That's it for the simulation. We're gonna continue.
This is the initial layout FlexSim simulation result. Next. And this is the proposed layout FlexSim simulation result. Next.
This is the FlexSim simulation result on the initial layout and the proposed layout. Through the layout simulation, it can be found that the output increase is 58.62%. And this is the state time comparison of the FlexSim result in the production process, where there is a decrease in the proposed layout simulation, which can be seen on the screen.
And this is the conclusion of our research with the proposed new layout chosen with alternative to SLP method can reduce the distance 53.42%, moving moment 17.186%, and material handling cost decreased by 50.12%. Also on the pro model simulation, there is decrease on average time in system by 21.82%, decrease on average time in operation 22.36%, and increase of production by 15.29%. And based on the FlexSim, there is some increase for the production per day by 58.62%, and also decrease on the stay time by 33.47%. Next. This is the reference that we use for the research that we've done. Next. Now I'm gonna open the question and answer session. I'm gonna give it back to the session chair. Thank you.
Thank you very much for your next presentation. So I would like to open the floor is your question.